Bismillahirrahmanirrahim. Assalamualaikum. This video is a video about chapter 6, which is functions and graphs, for the subtopic of transformation of functions. So these are the members of our group. This is our table of contents. First, definition. Second, content. Next, example, real-life application, exercise, and conclusion. First of all, what are transformations of functions? This is the processes that can be performed on an existing graph of a function to return a modified graph. We normally refer to the parent functions to describe the transformations done on a graph. Next, content. In this chapter, we can use Desmos, graphing calculator, GeoGebra, and many other types of tools. Next, in this subtopic, we also learn about vertical shifts, horizontal shifts, reflections of graphs, vertical stretching, vertical shrinking, horizontal stretching, and horizontal shrinking.
So for the example 1, we start with the vertical shift. So the question asks, use the graph of fx equals to absolute x to obtain the graph of gx equals to absolute x minus 2. Okay, so how we gonna solve this question? So to solve this question, we use mathematics software, which is Desmos. Alright, so how we gonna use this software? So firstly, we insert this equation first. Alright, we insert this equation first for our first value. Okay. Fx equals to absolute x. Okay, so see the pattern. The pattern in the graph has been shown. Okay, so for the next one, we insert this equation. Okay, gx equals to absolute x minus 2. Okay, alright, so see the pattern of the graph. The pattern of the graph shifted downward. See? It shifted to the negative 2, 0, negative, 0, negative 2, 2, 0. Okay, so this is the vertical shift for the graph. Alright, for the next one, example 2. Horizontal shift. So the question asks, use the graph of fx equals to square root of x to obtain the graph of gx equals to the square root of x plus 3. So it seems goes as we solve the vertical shift question, we use the Desmos software. Okay, we use the Desmos software. So we insert the first value, which is fx equals to square root of x. Okay, fx equals to square root of x. Okay, so as you can see, the pattern of a graph has been shown with a plot of 0, 0. So to solve our question, we insert the second value, which is gx equals to square root of x plus 3. Gx equals to square root of x plus 3. Okay, as you can see, the graph is shifted to the left, which is the plot is negative 3, 0. Okay, So why the graph is shifted to the left is because this plus symbol or positive show that this graph will go to the left. If we change it to minus of negative symbol, it will shift it to the right. So for our question here is gx equal to square root of x plus 3. So it will shift it to the left, and the plot is negative 3, 0. So this is the horizontal shift graph.
Assalamualaikum warahmatullah. I'm going to continue with the real life application transformation of function. When the terms come our mind, the real life application or real life, that we come to know the real life, what is the purpose of it, what is use of it, that particular topic, a particular function, a particular subject. In this case, I'm going to talk about the transformation of functions. Okay, let's jump into the topic. The function transformation in mathematics. Transformation are used to move geometric shape around a coordinate plane in geometry class. Function transformation can be applied to more complex equations such as logarithmic and trigonometric equation in geometry class. Function transformation can be used to graph or find the formula for graphs that are not easily found otherwise. In real life, the transformation function. Okay, the animation requires a figure to be shifted and stretched on a plane. Computer animation software use advanced transformation to achieve this. Let's say if the function are used to model data, a shift in data can be reflected by a function transformation. Okay, I'm going to demonstrate a application, how to calculate the function transformation. Okay, let's demonstrate a application where we can calculate the transformation function. In this case, I choose the GeoGebra.org. Is the web-based application that can calculate the transformation of function. When we try to put the equation here, then the graph will show the transformation of the graph, that where is the calculation. Okay, let's say we try to put the fx equal x square, so the graph is the transformation calculate exactly where is the x square, and also can select with the pointer. Okay, the point -2, -2 and +2. The calculation will shows here that where is the point exist. Okay, and the got several tools here. The move, point, slider, intersect. That's all for me. Thank you so much.
First, we're using a concept. For question number 1, when examining the formula of a function that is the result of multiply transformation, how can you tell a horizontal shift from a vertical shift? Question 2, how can you determine whether a function is odd or even from the formula of the function? So here is the answer. For number 1, a horizontal shift result when a constant is added to subtract from the input. A vertical shift result when a constant is added or subtract from the output. For question number 2, for a function, substitute negative x for x in the fx. Simplify if the resulting function is the same as the original function. Then the function is even. If the resulting function is the opposite of the original function, then the original function is odd. If the function is not the same or the opposite, then the function neither odd or even. So the next question is, describe how the graph of the function is a transformation of the graph of the original function f. So for question number 1 is fx minus 4. So the answer is the graph of fx minus 4 is a horizontal shift to the right 4 units of the graph of f. The answer for question 2, the graph of G is a horizontal reflection across the y-axis and a vertical range by a factor of 3 of the graph of f. And for question number 3, the graph of fx plus 8 is a vertical shift up 8 units of the graph of f. So for the next question about graph transformation of basic function. So begin by graphing the standard quadratic function fx equals to x squared, then use transformation of the graph to graph the given function. Number 1, gx equals to x minus 5 squared plus 2. Number 2, gx equals to 4x plus 1 squared minus 5. So for the answer, first we need to know that the graph for y equals to x squared is like this. So for the answer, we can see that the graph is shift right 5 units and up 2 units. So the domain and range is 2 and infinity. The reason why we need to shift 5 units to the right because x minus 5 is equal to 0. And we get that x equals to 5, so it's a positive. That's why we shift it to the right. The answer for question 2, we can see that fx equals to x squared is shift to the left 1 unit and stretched vertically by a factor of 4 and shifted down 5 units. So here is the graph of gx equals to 4x plus 1 squared minus 5. The next question is graph transformation of a basic function. Begin by graphing the standard quadratic function fx equals to square root x. Then use transformation of this graph to the graph given function. So the answer for this question, firstly, we need to know the graph of y equals to square root x. So here is the graph of y equals to square root x. Here is the graph for gx equals to square root x minus 5. So we can see that 5 unit will shift down. So here is the answer for question number 2. The graph gx equals to negative 1 over 2 square root x minus 3. Given fx equals to modulus x, sketch a graph of hx equals to fx plus 1 minus 3. The answer is the function f is our toolkit absolute value function. We know that the graph has a V shape with the point at the origin. The graph of h has transformed f into 2 ways. Fx plus 1 is a change on the inside of the function, giving a horizontal shift left 1. Then the subtraction by 3 in the fx plus 1 minus 3 is a charge to this outside of the function, giving a vertical shift down by 3. Write a formula for the graph shown, a transformation of the toolkit square root function. So the answer is the graph of the toolkit function start at the origin. So the graph has been shift 1 to the right and up 2. In function notation, we could write that as hx equals to fx minus 1 plus 2. Using the formula for square root function, we can write hx equals to square root x minus 1 plus 2.
Finally, the conclusion from this subtopic is transformations involving more than one transformation can be graphed performing the transformations in the following order: horizontal shifting, y equal fx plus c, y equal fx minus c; stretching or shrinking, y equal cfx, y equal fcx; next, reflecting, y equal negative fx; and lastly, vertical shifting, y equal fx plus c. That's all from us. Thank you.